Hi everyone. Now I am going to discuss about the relative motion in two dimension. Okay, 2D I am discussing. Before that I am just giving that what is the relative velocity. Earlier we have written that relative velocity is VAB bar is equal to, we have written VA bar minus VB bar. Same logic we are going to apply for the two-dimension motion. Okay, I will tell what is a VA bar minus VB bar. Suppose say a body is moving with velocity A is moving like this, VA bar. Okay, and B is moving in some other direction. Velocity of the B is like this is there. If you want to write the velocity of A with respect to B, you can write it as VAB bar is equal to VA bar minus VB bar. Now you can see VA bar is right side is there. Okay. VB bar is upward direction is there. But you don't want VB bar. We want minus VB bar. I have written minus VB bar. I can make a parallelogram. This is VA bar and VA bar and VB bar, VA bar and minus VB bar. Now you can observe that the resultant velocity or whatever relative velocity is there, this is VAB bar direction. You can calculate like this and use the theta, whatever theta is there between the relative velocity resultant vector with A bar or with VB bar. Anything you can calculate. This is a basic relation. The basic relation you can apply anywhere and everywhere. Okay. I am going to use now. First one is riverboat problems. Riverboat problems. What basic concept you have studied in riverboat problems, I am going to write that relations only. Okay, let us consider that given is a river. Okay, in this river what I am taking is there are the 2 points, point A and exactly other side there is a point B is located. Okay, now a person is who is going to swim. Suppose if he is swimming like this, this is the velocity of the man with respect to river. Assume that river flow is like this is the right side. Okay, man is going to move in particular direction. Velocity of river is right side is let us consider that he makes an angle theta with velocity of river. Okay, I am writing usual meanings here. VR is velocity of river. Velocity of river. VMR is velocity of man with respect to river. Velocity of man with respect to river. Okay. Now I am taking VM bar is velocity of man. This is actually with respect to the ground. Now, according to our relation, velocity of the man with respect to river is equal to velocity of the man minus velocity of the river. You can write velocity of river is equal to velocity of the man with respect to river plus velocity of the, I am writing velocity of the man. Velocity of the man is equal to velocity of the man with respect to river plus velocity of river. Now you can see our main result. So this is the velocity of A and velocity of the minus VB is there. Then we have seen that the resultant velocity is there between the A and B. Okay. Now you can see in this case my resultant velocity Vm bar, I am writing this, I am rubbing this line. Velocity of river is there. Now I am writing left side VR bar. Now I can see velocity of river is right side is a velocity of man is going like this. Okay. Now, if any person is moving with respect to river like this, a given line like this he is going, velocity of the man with respect to ground will go other direction. Now, he is making an angle alpha with the horizontal direction like velocity of river. Okay. By using this, we can write the its components like this. So, tan alpha can be written as velocity of river plus velocity of the man with respect to river. Sorry, opposite component I would write now. Velocity of river along y-axis divided by the velocity of not river. Sorry, I'm writing every time. Velocity of man with respect to river already VMR is there. Velocity of man along y-axis divided by the velocity of man along x-axis we have to write. Velocity of man along x-axis means what you will get? You can see VMR is this direction is there. You can make the component is VMR cos theta along y-axis VMR sin theta you will get. You can get the VMR sin theta divided by the VMR cos theta plus VR we can get. Now, in this time, you can see the person is actually reaching to some other location. Let us consider C on the ground. This X is there, that is called width. Drift. That is called drift. Drift is nothing but horizontal distance covered. Distance covered by the man. That horizontal distance I am writing here. X is equal to velocity of the man along x-axis into time taken t. How much distance he is traveling here? X distance. How to calculate time? I can take this is the width of the river is W. I am writing like this. Now you can see whatever the time taken is there, time taken can be written as opposite component divided by the velocity of man along y-axis. Substitute there, x is equal to Vmx. Vmx is Vmr cos theta plus Vr. Vmr cos theta plus Vr into t is W divided by the velocity of the man along y-axis. By using this, you can calculate the distance traveled. By using this relation, you can calculate the whatever the velocity. Vmy already you know that Vmy is equal to Vmr sin theta. Okay. By using these relations, you can calculate time taken, whatever distances are there, everything you can calculate. This is one of the situation. Different situations are there, as per that you have to follow. Okay. Now I am taking some conditions. Condition to cross the river in shortest time or minimum time. He wants to cross the river in minimum time. To cross the river in minimum time, he has to go like this only. Every time he has to go perpendicular to the river. Now you can see this is the point A, other end B point is there. Now as river is flowing right side with velocity A right side, river means everywhere river is there. River is flowing right side. Now a person is asked to go like this. Velocity of the boat or man, anything. Velocity of the man with respect to river should be like this. He should make an angle 90 degrees with the y-axis. Okay, 90 degrees with the river flow. Okay, he should swim 90 degrees to or perpendicular to river flow. Perpendicular to river flow. Okay, this is an important point. Or we can say perpendicular means actually we can say theta value is equal to much 90 degrees should be there. Theta is equal to much 90 degrees. If you want, we can check here. Here Vmy is equal to Vmr sin theta is there now. When you will get Vm is equal to Vmr sin theta. So for T minimum, you have to get the W divided by the VMY maximum value how to write. What is a VMY? This is a VMR sin theta is there. So for that, this theta value should be maximum value. Then sin theta value is 1. So sin theta should be 1. Theta should be how much here? 90 degrees. That's why I have written 90 degrees. So now minimum time can be written as T minimum value is equal to W divided by the velocity of the man with respect to the river we are getting. VMR. This is a minimum time. Whenever minimum time is reaching there, we can see that as river flow is right side is there. Now as per our general relation triangular law method, we can see velocity of the man with respect to ground will be like this. Now in this case, he traveled a distance x, that is drift. Okay, in this case, drift can be written as x is equal to, drift x is equal to, we can write it as velocity of the man along x-axis into time taken t. Okay, man along x-axis is only VR is there and the time is W divided by the VBR is there. This is the drift in shortest time. Okay, now if you want to calculate velocity of the man, velocity of the man can be written as under root of VR is along x-axis is there, VMR is there along y-axis. So you can write it as VR square plus VMR square. This is the velocity of the man. Okay. Now if you want to calculate displacement, you can see as per the question, you can see displacement of the man can be written as width is W and drift is x. Displacement S can be written as displacement S is equal to under root of W square plus X square. These are the relations you can identify. This is the condition I have given to cross the river in minimum time. In any problem, if they mention the minimum time, man with respect to river should be like this. Okay. Next one. Other condition I am taking. Condition to cross the river in shortest path or minimum drift. Now you can see how he has to move. Now this is a person A starting from A and he is reaching the B point, exactly opposite point. Okay, he wants to reach that. Suppose say a river is flowing along x-axis like this, horizontal flow is there. If we move like this, he is reaching like this. Okay, if he go like this, then he will reach another location. That's why to reach B point, he should move in upstream. Okay, that's why I'm writing. I'm drawing neatly, you can see it. To reach B, he should move in upstream. This should be the velocity of man with respect to river. Let us consider he is making angle theta with the y-axis, and whatever drift is there, I am taking this as W. Width of the river is W. Okay, river flow is like this. This is the velocity of river. Man is going like this. Okay. Now I am writing he should move upstream. Okay, to get minimum drift, man should swim in upstream. What is the meaning of upstream? Upstream means swimmer is moving opposite to river flow. Okay, this is the meaning of river, upstream meaning. Okay, similarly downstream means swimmer direction is along the direction of the our swimmer is moving along the direction of the river flow. Next one. Now he has to go in upstream now. If he is moving in upstream, he will reach in a shortest path. Suppose say if you want to get the zero drift. For zero drift, x is equal to 0. X is equal to 0 means exactly he will reach to point B. Okay. Now this is the velocity of the man. Man should move perpendicular to this. Here not VMR. I am writing VM. With respect to ground only, man is reaching to B. Okay. With respect to ground, he should go in straight line only with respect to ground. Okay. In that case, we can say that velocity of the man is equal to under root of VMR square minus VR square. Conditions I am writing here. And time taken, T should be equal to W divided by the velocity of the man. W divided by under root of VMR square minus VR square. And what direction he has to move? So, person should swim with an angle. We can see how much angle he is going now. He is moving like a theta and 90 degrees with the river flow. River flow is like this is it. We can write this as swim at an angle 90 degrees plus theta value. What is theta here? You can write sin theta value is equal to, from the figure we can write VR by VMR. VR divided by the VMR. So you can write sin inverse of VR by VMR with the river flow. You should swim like this. Okay. These are the relations to get the zero drift. Okay. This above relation is possible. This relation is possible only when VR is less than VMR. If VR is greater than VMR is there, then he has to move like a theta should be equal to sin inverse of VMR divided by the VR. Kindly keep in your mind, this is the relation if VR is greater than VMR. Okay. These are the conditions you have to keep in your mind while doing the problems of these riverboat problems. Okay. In this case, if VR is greater than VMR, in that case, man is obviously, whenever he is moving with velocity of man with respect to river like this, he never reach the B point. Always he will reach the some other location only. C point he will reach. Always X will be there. He never reach B. In this case, if VR is greater than VMR, he never reach B. Always he will reach some other location. Okay. These are the some points I have given for the riverboat problems. Now we are moving to the some other relative motion like rain umbrella problems. Rain umbrella problems. Observe this carefully. Let us consider that a man is standing here on the road. Man is at rest. If rain is falling like this, this is the velocity of rain. Okay. Let us consider the next time he is moving. Man is moving. Now I am writing man is, let us consider the man is moving. I am taking a man is moving. And he observed that rain is falling vertically downward direction. Again he observed that velocity, rain is falling vertically downward direction. I am writing VR is the velocity of rain. Velocity of rain with respect to ground. Velocity of man is VM, velocity of man. Velocity of rain with respect to man I am writing as VRM. Okay. Now, whenever the person is moving like this, now rain is falling now, he should protect himself from the rain. Okay. Now, for that, what he has to do here to protect himself, to protect himself from rain, he should hold umbrella with an angle theta with vertical. What angle he has to hold umbrella? You observe this. He has to hold umbrella like this, and the rain is falling vertically downward. This is the velocity of rain. Man is moving like this, velocity of the man. You should hold umbrella like this, velocity of rain with respect to man. Okay. Now what I am doing is I will reverse this. Velocity of man is right side is there. Velocity of minus man is left side will be there. This is a theta. We can see if you want. Velocity of rain with respect to man is equal to velocity of rain minus velocity of the man. Now you can see velocity of rain is positive, velocity of man is negative. Now from this we can say that tan theta value is equal to Vm divided by the Vr. So theta is equal to tan inverse of Vm divided by the Vr. This is the angle he should hold umbrella to protect himself from the rain. Okay. Some other conditions also I am giving, you can observe this. Let us consider the one condition. Rain is falling like this, man at rest. Man at rest. Okay, this is the velocity of rain. Now you write the some different conditions. I am writing different conditions. You can see. Suppose say man is moving with v1 speed. He observed that rain is falling with respect to the man is like this. How it is falling? Let us consider that it is making angle theta 1. Still velocity of rain will be downward only. Why? Because velocity of rain is not operated by the person. Velocity of rain is from coming from the sky. Understand that? From there it is coming. Velocity of rain with respect to man is actually, if you move, the direction of the rain with respect to man will change. In this case we can write it as tan theta 1 can be written as V, opposite side is Vr divided by the V1, velocity of man. Still, suppose say if he increases his speed V2, man increases speed to V2. In that case, we can see that, let us consider that this time velocity of rain with respect to man is making some other angle, theta 2. Still I am telling velocity of rain is downward direction only. Why? Because whenever man is at rest, rain is coming from the like sky, it will fall downward only. Okay, so you can say tan theta 2 is equal to Vr divided by the V2 will write. By using this, we can calculate the whichever unknown terms are there, we can calculate by using these relations. Observe this carefully. Velocity of rain or any other angles if they ask, we can calculate. Okay. Next one, wind aircraft methods are there. That wind aircraft methods also, I will just write the relation. Wind and aircraft methods are there, that I will write. This here only I will write. Wind aircraft methods. Wind aircraft problems. Same process, velocity of aircraft with respect to wind can be written as velocity of aircraft minus velocity of the wind. VA bar is indicates that velocity of aircraft V W bar is velocity of wind, and this is velocity of aircraft with respect to wind. With respect to wind. These are the relations. Now you can observe this. Now I am going to use the problems from the JEE mains exam. We can observe this. First question, a person standing on a open ground hears the sound of a jet airplane coming from the north at an angle of 60 degrees with the ground level. But he finds the aeroplane right vertically above his position. If V is a speed of sound, the speed of the plane is what? I am writing. You can observe that a person is standing somewhere here. Now he observed that a plane is somewhere. This plane is producing the sound waves. Whenever it is moving forward direction, we can see plane reaches to the some other location. Let us consider plane is reaching to this point. Let us consider that this height is equal to L. Now he hears the sound. How sound wave is coming? From plane, sound waves are coming like this. From plane, sound waves are coming. This is the velocity of sound given that V. Okay. He observed that this sound is making angle 60 degrees with the ground. Now the distance traveled by the sound is I am taking L. What is L? L is actually, you don't know that. Let us consider that distance is D. D is distance traveled by sound wave. Okay. At the same time, you can see the velocity of the plane I am taking Vp. Vp is velocity of plane. V is velocity of sound. Now you can see that L they have not given. L is a perpendicular distance just. Now we can see that how this is actually happening. This sound wave actually produced. Sound wave is produced when plane is here at point A. At A. When he receive when plane is at B, person hear the sound wave. Okay, observe this. Now I am writing like a distance travel time for sound wave. T is equal to distance by velocity. Distance is nothing but L cosecant 60 degrees divided by the V. Time for plane from A to B. Meanwhile, that time it is traveling from A to B. So you can say T is equal to distance AB divided by the velocity of the plane. Distance AB is L cot 60 degrees divided by the VP. Now both the times are equal. So you can say from first equation and second equation, you can write the relation as L cosecant 60 degrees is root 3 by 2 divided by the V is equal to L cot 60 degrees is 1 by root 3 whole divided by the velocity of the plane. Now you can see L and L get cancelled. Cosecant 60 degrees value you can write it as 2 by root 3. 2 by root 3. Now you can write the root 3 and root 3 get cancelled. So finally you can write the velocity of plane can be written as V divided by the 2. This value. Observe this, you will get the third option. Okay. Now we will see that next question. According to next question, ship A is traveling towards the northeast with a velocity V bar is equal to 30 I cap plus 50 J cap kilometer per hour. where I points east and J points north. Okay, ship B is at a distance of 80 kilometer east and 150 kilometers north of ship A and sailing towards west at 10 kilometer per hour. A will be at a minimum distance from B. So yesterday in the last video I have given that if there are the two ships are there, I am taking this as ship A, which is moving with velocities. We can see 30 I cap and 50 J cap. Now there is a one more ship B which is moving towards the west 10 minus I cap. It is moving like this, ship B. Now if you see the location between them is along x-axis 80 kilometers is there, along y-axis 150 kilometers are there. Okay, now A will be at a minimum distance from B's. Okay, now you have to calculate velocity. This is the velocity of the B. Velocity of A with respect to B can be written as velocity of A bar minus velocity of the B bar. Velocity of A bar is 30 I cap plus 50 J cap minus 10 I cap is the velocity of B bar. We can get the 40 I cap plus 50 J cap. Okay, now I am taking this as a some particle type. See here, A point, this is the B point. Okay, now I am writing how this B point is moving. Okay, now A with respect to B is somewhere here like this is there. This is the velocity of A with respect to B, 80, and this is a 150, and velocity of A with respect to B value I have written. Now we want what is the minimum distance from the B. Means actually you should draw a line perpendicular to the B bar you have to write. Okay, and the time taken they are asking. The time taken can be written as, if I write the minimum value like a 150 and 80 is there, that AB distance is there. Now that I am writing T is equal to AB divided by the distance between the A and B initial positions. Okay, AB divided by the VAB bar is there. Now that I am writing magnitude. So if I write the T is equal to AB value is equal to how much from the figure, under root of 150 whole square plus 80 square. We can write under root of 22500 plus 6400. We can get like a 28900. We will get approximately 170 kilometer. Not approximately, directly we will get 170 kilometers. Now time can be written as 170 kilometers by VAB bar under root of 40 square plus 50 square. Use that. T can be written as actually kilometers I am removing, other thing also there in terms of the kilometers only. Finally we will get in hours. Okay, 40 square plus 50 square, you can write the 1600 plus 2500. So you can write a 4100. 170 17 by root 41, this value approximately 2 point something will get 2.6 hours is there. You can write 2.6 hours is the time taken approximately. Okay, this is the value. Minimum distance from B is, okay, 2.6 hours we can get. Next question. You can see the stream of river is flowing with a speed of 2 km per hour, can swim at a speed of 4 km per hour. What should be the direction of the swimmer with respect to the flow of river? This is a direct question only, they have asked in JEE mains. River is flowing, VR is equal to, you can see 2 km per hour. Okay, now what should be the direction of the swimmer with respect to the flow to river to cross the river straight? Now he wants to go like a velocity of the swimmer or stream, whatever thing is there, he has to move in direct. So to get the direct B point, exactly opposite point, he should go like this. Velocity of the man with respect to river is like this. Now if you see what is the angle it is making. So 90 degrees plus theta is equal to sine inverse of VR divided by the VMR. VMR value is given 4. Okay, you substitute there alpha value I am writing 90 degrees plus sine inverse of 2 divided by the 4, that is 90 degrees plus 30 degrees 120 degrees with river flow. With the river flow, that is the formula based question. Fourth option. Next one. When a car is at rest, a driver sees raindrops are falling on it vertically. Let us consider that there is a car. This car, actually, whenever car is at rest, raindrops are falling vertically downward direction. This is the velocity of rain. Car is at rest. Now, you observe this carefully. In the next case, what they are giving is next case, when car is actually moving with a velocity v, the raindrops are actually falling like this. Velocity of rain with respect to man, making angle 60 degrees. But velocity of rain is still like this only. Okay. In this case, we can write tan 60 degrees is equal to velocity of rain with respect to man by velocity of rain divided by the v. V is the velocity of the man. So we can say that root 3 is equal to VR by V. From this VR is equal to, we can write it as root 3 into V. In the next case, we can observe that whenever the car is increases its speed, okay, let us consider the value according to question 1 plus beta into V is given. I am writing 1 plus beta into V is the speed. Now again you can see, as per the question, it is making an angle 45 degrees. Velocity of rain with respect to man is given 45 degrees. Still velocity of rain will be downward only. Okay. Now you can see tan 45 degrees can be written as velocity of rain divided by the velocity of man. Okay. Velocity of man is there, no? That I am writing, that is V into 1 plus beta. As tan 45 degrees is 1, we can write it as velocity of rain is equal to V into 1 plus beta. Velocity of rain is root 3 into V, that is equal to V into 1 plus beta. Now you can see that V and V get cancelled. Now beta value can be written as root 3 minus 1. Root 3 is 1.732 minus 1. You will get the finally 0.732. This is the beta value. You can see third option is the correct option. Okay. Next question, a particle is moving along the x-axis with its coordinate with x of t is given as well as y of t is given. At t is equal to 1, what is the relative velocity they are asking. As per the question, position x of t can be written as 10 plus 8t minus 3t square. We can get v is equal to dx divided by the dt, that is I am writing vx. 8 minus 6t. At t is equal to 1 second, we can write vx is equal to 8 minus 6, that is equal to 2 meter per second. Similarly, if you write the y of t can be written as 5 minus 8 cube, 8t cube. Y divided by the dt can be written as Vy. The value is minus 24t square. At t is equal to 1, we can write Vy value is equal to minus 24 meter per second. Now you can see what is the velocity of A with respect to the velocity of second particle is as measured in the frame of first they are asking. Velocity of the B with respect to A, if you write that, we can write it as velocity of B is this is velocity of the B is equal to minus 24 meter per second j cap. Velocity of A bar can be written as 2 I cap. VB bar minus VA bar minus 24 j cap minus 2 I cap. If you use that magnitude value, B with respect to A can be written as under root of 24 square plus 2 square. We can get the root 580. According to question, root V value, V is how much? 580 value we get it. Okay. Next question you can observe. A person is swimming with a speed of 10 meter per second at an angle 120 degrees with the flow and reaches to the point directly opposite on the other side of the river. The speed of the flow is x meter per second. The value of x is equal to much. This is also direct question they have asked from the formula based only. Now he wants to reach there, and there is a velocity of man with respect to river 90 degrees, and total angle is given 120 degrees, so you will get the 30 degrees is this. Velocity of river is opposite direction. Okay, velocity of man with respect to river is equal to 10 meter per second is there. Now if you write that sin theta value can be written as VR divided by the VMR. Sin theta value they have given here 30 degrees is there. Theta is equal to 30 degrees. Now 1 by 2 is equal to VR is x divided by the VMR value is 10 is given. So x is equal to 10 by 2, we will get the 5 meter per second. 5 is answer. Next question. A girl is standing on the road, holds an umbrella at 45 degrees. Now you can see it. With horizontal or vertical, you can see 45 degrees with vertical. And to protect himself, VRM is that side. If she starts running without umbrella, with a speed of 15 root 2 meter per kilometer per hour, the raindrops hit her head vertically. Nothing but we can see here. This is the velocity of rain only. Okay, she is at rest now. Girl is at rest. Now, next case, when girl is moving with 15 root 2 kilometer per hour, she observed that raindrops are directly striking her. Velocity of rain with respect to man is like that. Now still we can observe that velocity of rain is making angle how much here? 45 degrees only with horizontal, and similarly with vertical. Okay, now according to question they are asking what is the velocity of rain with respect to the girl. Okay, tan 45 degrees we can write it as velocity of opposite direction. We can write velocity of the rain with respect to man divided by the velocity of the man, that is equal to 1. So we can write velocity of rain with respect to man is equal to 15 root 2 kilometer per hour. This is velocity of man. Okay, according to question, according to options, we can see 15 root 2. 15 root 2 is nothing but that is also can be written as 30 by root 2 kilometer per hour. Option 3 is the correct. Next, this is a old JEE advanced question. A boat which has a speed 5 km per hour in still water crosses a river width 1 km along the shortest possible path in 15 minutes. Velocity of the river water in kilometer per hour is equal to how much they are asking. You can see here velocity of the boat speed is given, nothing but VB is given, velocity of the boat is given 5 km per hour with respect to river. Similarly, you can see width is given 1 kilometers. Next, time taken T is given 15 minutes. 15 minutes is nothing but you can write it as 1 by 4 hour. Okay, now velocity of river is equal to how much? They have given shortest possible path it is moving. Whenever it is moving shortest possible path, we have like a velocity of river and time, these relations are there. Now that we can write T is equal to W divided by the under root of V B R square minus V R square. Substitute there. 1 by 4 is equal to W is 1, under root of VBR square is 25 minus VR square. Squaring on both sides, 25 minus VR square is equal to 16. We can get VR square value is equal to 9. So VR value is equal to 3 kilometer per hour. So we can write the 3 is the answer. Okay. I have given shortest possible path. What is the time taken formula already I have explained. We can check that. Okay. Next question. This is the last question. A river is flowing from the west to east at a speed of 5 meters per minute. So you can see from west to east, this is the west and this is the east. West to east it is traveling. The velocity of a river is equal to 5 meter per minute is given. Next, a man on the south bank. So you can see south bank. Let us consider this is the river. From south bank, this is the south. Man on the south bank of the river, capable of swimming at 10 meter per minute in still water. Okay. He wants to swim across the river in a shortest time. He should swim in a direction. Direct question they are asking. We can see whatever VR value is there. I will write like this. VR is equal to 5 meters per minute. Now you know that velocity of the man with respect to river should be 90 degrees with the river flow with east direction. Okay, and he should go towards the north direction. Okay, exactly perpendicular to east he has to go. Here north direction he has to swim due to north direction. Okay, these are the few questions available for the JEE mains and the JEE advanced. I hope you have gone through this video lecture properly. In the next lecture I will give that circular kinematics. Okay, we will continue in the next video. Thank you very much.